All right, guys, so it got erased here, but the solution to number 8 should have been -6, -2, -1, -4, and -2, -2, okay? All right, so moving on to number 9 here. Number 9 is different because now we are reflecting over the line y equals x, okay? So the first thing we're going to do is plot those points for triangle x. All right, so we have those coordinates plotted there. It's a triangle. Now, the line y equals x, that has, since it's just y equals x, and normally there'd be like a number. So normally we're in see things like 3x plus 5. Well, here what we're doing is we're just taking away that plus 5, which means it's actually saying plus 0, and we're taking away that, meaning that it's just in the form of this, 1x plus 0. All right, so if we're graphing 1x plus 0, that means that it's going to start, the y-intercept is at 0, and it's going to have a slope of 1 over 1. So if we go up 1 over 1, then we are left with that point right there, and that point, and that point. So we are just going to draw a line connecting all those points, and same thing, draw a line connecting all those points. Ooh, I don't know what happened there. Draw a line connecting all these points. All right, so that's the line y equals x. Okay, that brown line right there, that's y equals x. So for this, if you look at z, okay, it's really kind of confusing because it looks like we're going a diagonal to get to that line, because normally we were counting. I think that was the easiest way to do it. But before, there was other different patterns too. Like, if some of you guys might have caught on to it, but like if you're reflecting over the x-axis, all right, if you're reflecting over the x-axis, all you got to do is change the sign of the y-coordinate, and it just, if you're reflecting over the y-axis, all you got to do is change the sign of the x-coordinate. So there's patterns there as well, but I think it's sometimes just easier to count to the line of reflection. Here, it's hard to count to the line of reflection, okay? You're going to be left with kind of halves. It's going to get a little bit sketchy here. So what we want to do, there's simple trick, okay? Simple trick. So for this, anytime, and this would be good to write this down somewhere, all right? So anytime we're reflecting over this line, y equals x, all you have to do is, let's say we start out with an x and a y coordinate, okay? When we reflect over this line, all we're going to do is we're just going to switch them, and it's going to become y comma x, okay? So this is the thing. This would be a good time to pause the video, write that down just so you have it with you. That rule right here, okay? All right. So just give me some more space here. If I'm looking, just for instance, if we start off with x, okay, we have our x and our y value. So all we're going to do is we're just going to switch the order of those, that ordered pair, and we're going to make it -2, -5. All right. And if we plot -2, -5, that's going to be right there. That's going to be our x prime value, okay? And as you can tell, looks about right. I mean, it looks like it's in the right position. It looks like it's about the same distance because it is, okay? So that's what we have to do for these. So when we're solving these, we just switch the x and y coordinates. So for y, it's going to be 4, -3. So for y, we're going to go over 1, 2, 3, 4, down 1, 2, 3. That's going to be our y prime value, okay? Last one is z. We're just going to switch it up and make it 1, -1. All right, so 1, -1 is going to be right there. And I think z might be the easiest one to see. That z is kind of diagonally 1 unit away. But for this, it makes it real nice because it's like, oh, well, it's right there. We can see it. So for this, we are going to connect the dots here. Oh man, why is that? Here we go. So we're going to connect the dots here. All right, and that's going to be the reflection of our image. So I'll put the coordinates down here in the next video.